Hey folks, welcome to the channel. In today's build, we're going to start a new knife, a chef knife. This one is going to be CPM-154 stainless steel, so mostly stock removal. Let's get at it.
It looks like the blade on my portaband is just too dull right now, and unfortunately it's my last one. Off to the angle grinder. I'm fixing up the profile a little bit after the angle grinder, and then we'll switch to horizontal mode and smooth it all out. This is a little different profile than I normally do for chef knives. In this one, the spine is at an angle which continues up the handle, which moves the handle up away from the cutting board. So it's kind of a cool design. Another thing I'm doing in this design is moving the heel of the knife closer to where you pinch grip it. So it's actually underneath your fingers as you're cutting, which is where you want it.
So I got the profile done on this knife. I'm actually going to heat treat this thing and do all the grinding after, just because it's much easier to heat treat it between the aluminum plates, because this is stainless steel. It'll go between aluminum plates and not oil if it's perfectly flat. So what we need to do is put it in some stainless steel foil. It's got to be wrapped up tight so no oxygen gets into it. And if we look at our recipe here, we're going to set the oven for 1400, soak for 10 minutes, ramp to 1950, soak for 30 minutes, and then plate quench.
Right after I'm done quenching the blade between the aluminum plates, it's going to go into cryo, and for that we're going to use dry ice. This is an important step for stainless steel blades because it adds a couple points of hardness to the knife.
So I'm just using dry ice here, so I'm just going to place the blade between blocks of dry ice. It always buzzes like this. I've done the slurry of acetone, and it's just not worth it. It's way too messy. This pretty much does the same thing as far as I'm concerned. It still chills the blade down beautifully. Okay, let's check the hardness on this blade.
The test you're seeing now is after tempering. I did one pre-temper, and it came out at 65 HRC.
We're at about 62 and a half.
I always repeat the test 2 more times and take an average.
Yep, exactly the same. So 62 and a half. That's pretty good.
Now it's time to take this to the surface grinder. The stock I started with was 3/16 thick, and I need to get this down to about 3/32. If you're interested in getting into knife making and you want to learn how to grind, watch my Thursday video. I'll put a link up in the corner. It's about knife grinding basics. Since I did all the grinding post heat treat, it took a lot longer than normal. This knife is really hard. Now that I've put in the initial bevel, I'm switching to the Broadback incinerator belts. These are awesome. Links down in the description if you need some. After a couple hours, I was done the grinding on this knife with a 36 grit belt. I ended up moving all the way up to an 800 grit belt and then a surface conditioning belt. Broadback has these new game changer belts that are aluminum oxide belts that are really, really nice. And that's what I ended up using all the way up to 800 and then their surface conditioning belt.
So ready to start the handle on this. I've got it ground to 800 and then hit it with a surface conditioning belt. I actually did no hand sanding on this blade, so you'll see how it turns out at the end. So for hand materials, we're going to use this. I'm not even sure what kind of wood it is. This is another blog from Oleg. I'll put his link down in the description. It has awesome stuff. But this one's kind of bluey, purple, green and purple colors. It looks really cool. I'm going to be doing, instead of a metal bolster, I'm going to be using G10 for the bolster here, with a piece of white G10 in the center. So it'll look something like that.
Right now I'm just gluing up the bolster because I need to take this to the mill and mill the slot so it fits exactly right on the knife. Now I'm just marking out where the tang's going to be so that I can drill the hole. This is why you draw the tang on the side of the block. Now I can line up the drill bit. I like to drill the two outside holes, so now I'm going to reposition it and drill the other hole. Now you just drill more holes between these two and make them meet.
So I've got the bolster done. I put the slot in it in the mill. It fits up nice and tight. It still needs to be sanded. And then you saw me drill the hole for the handle. So, I mean, it's a little askew, but I need to square it up.
I decided for this handle, I was going to do a faceted handle, so it's very angular. So I needed the bolster to match. So that's what I'm doing now.
So I've got the spacer all sanded to 1,000, at least most of the facets. Some of them are going to be done afterwards. So that fits nicely. I've already done the hole and then squared up the handle and then taken this out, drawn this on where my pin's going to go. It's important to square up the handle before you try to drill your pinhole so it's not going in on an angle. Let's go drill that.
As always, I've removed the knife to drill the other side through. I've just placed a little mark on the tang so I know where to drill the hole. I didn't want to soften the tang here, so I ended up using a ball end mill to drill the hole through the tang.
All right, time for final glue up. I'm going to put some of this mica powder in here. It's kind of a black, but it's a bit shiny, just in case it comes out any of the seams.
This is exactly why you should always drill the hole in the tang a little bit bigger than your pinhole, because here I can compress the knife and make sure that there's a great fit and the pin's not stopping it.
So here it is after glue up. I just need to shape the handle a little bit. I've kind of drawn on some lines of where I want to take this, so let's get it done.
After getting the right shape on the handle, it's time to put those little facets on all the edges. I decided to use my 45-degree bevel jig for this, just so I could get them perfect. I ended up having to move the jig around so I didn't hit the blade on the grinder.
So folks, little hiccup. Sometimes it's just inevitable using burl. You'll get little cracks here. These are just kind of fissures in the burl, if you can see here, and I can feel these with my finger. So what I'm going to do, that you may have seen me do in other videos, I'm going to use some CA glue. So I'm a huge fan of this Starbond CA glue. It comes in all kinds of different colors and thicknesses. I'm using the medium here. It comes with these applicator tips, which are really cool. There'll be links down in the video description for this, and the channel gets a little bit of a kickback when you use those links. So I'm going to go and fill in all of this, and then there's an accelerator which will make it dry pretty much immediately. Great part about this stuff, it's already ready to sand. No waiting for it to dry. Sand it smooth and it'll be nice and clear. And just to show you guys how nicely this cleans up. And it's perfectly smooth now. I got a couple little places I might have to redo, but it's beautiful. Link down in the description for this stuff, guys. You definitely want to get some. Thanks for joining me on this build, folks. As always, I've learned a lot. That's the first time I've ever done a faceted handle like this. The first time I've ever really ground the whole knife after heat treat. So it was an interesting one, but this one came out really nice. Very, very hard blade and very sharp. Thanks, guys. We'll see you on the next one.